Hello, this is Mr. Stansbury. I'm going to take you through these two problems from the 11.3 Vertex form worksheet. Okay, so what we're going to do here first is it says write each function in vertex form, then describe the transformations from the parent function, and then C, sketch the graph of the function. So here's what we're going to do. We're going to use the quadratic formula. Scratch that, not the quadratic formula, only part of the quadratic formula. The x equals negative b over 2a, which gives us our axis of symmetry, right? Which is going to help us. Actually, this is going to give us the x coordinate of the vertex as well. So on this one here, a is negative 1, b is 4, C is negative 2. So if I'm going to plug that into the x equals negative b is 4 all over 2 times a, which in this case is negative 1. So we get x equals negative 4. 2 times negative 1 is negative 2. So negative over negative gives us a positive. 4 divided by 2 is 2. So we know that our vertex is going to be at the x is going to be 2, and since we know that the x is 2, we're simply going to plug 2 into this equation here and see what we get for y. So now we do y equals negative 2 squared minus, plus 4 times 2 minus 2. Okay, so we get 2 squared first is 4, and then we take that and multiply it by negative 1, so we get negative 4. And then 4 times 2 is 8, so plus 8, and then minus 2. So negative 4 plus 8 minus 2 gives us 2. So now that's going to be our y coordinate of our vertex. So our vertex is at 2, 2. Okay? Now it says write each function in vertex form. So since we know the vertex is 2, 2, here's what we can do. We can actually think of these as shifts, right? This shifted. This 2 means that we shift to the right. I'm going to write this somewhere different so we can see it better. So since our vertex is at 2, 2, that means we shifted to the right 2, and then we also shifted up 2, right? Because that's a positive 2. So, just like what we did on a couple worksheets ago, if we know what the shifts are, we can write this equation. And it's always going to start off with an x and our squared out here. Since it goes up 2, that means this is going to be plus 2. So that's going to be our y part. And then it goes to the right 2. So that means this is 2. 2 minus 2 gives us 0. So this 2 here is where that came from. And this here is in now vertex form. Okay. So it says write each function in vertex form, then describe the transformation. Look, we already described the transformation. It shifts right 2 and up 2 from the parent function, and then sketch the graph of the function. Okay. So we have our vertex. And now we can go back and we can do the same thing we did before. Well, actually, here's our new vertex form. So this is a 1 out here. So we are going to go from here. We're going to go, I forgot our negative. See how there's that negative out front here? So this really needs to be, before I write that other stuff in here, this really is a negative x minus 2 squared minus 2. So then when we go to put, so this negative right here is just going to come right along in here. Okay. So that means to get to our next point, we're going to go down 1 over 1, down 1 over 1 the other way, right? And then we're going to want to find our 2 other points. So we either plug in 0 or 4. I'm going to plug in 0. I think that'll be a little bit easier. So you can plug 0 into either one of these. And I'm going to actually suggest that you do it on this original one because there's a nice little, I don't want to call it a trick, but there's something that makes this really nice and easy. So negative 0 squared plus 4 times 0 minus 2. Look, this 0 squared turns into 0. 4 times 0 turns into 0. So this negative 2 here, that is going to be, that's actually what we call our y-intercept. Okay. But anyway, so if we plug in, we know that we get 0, negative 2 is another one of these points. So 0, negative 2 is another point. Here's our axis of symmetry. That's a distance of 1, 2 that way. So we go 2 more over, and there's our other point. So now we can, our fifth point. So now we can sketch our graph here. Okay? Okay, let's take a look at number 3 here. So we're going to want to start off with using our axis of symmetry formula. So we get x equals negative b is 12 all over 2 times a, which is 2. So this gives us negative 12 over 4, which gives us a negative 3. Okay, so that means for our vertex, we know that our x is negative 3. So now we can plug that negative 3 into this formula here to figure out what our y is, right? So y equals 2 times negative 3 squared plus 12 times negative 3 plus 16. So we get negative 3 squared is 9. We got to do this first before you multiply by 2, remember. 12 times negative 3 is negative 36 plus 16. So this 2 times 9 over here gives us 18 minus 36 plus 16, which ends up giving us negative 2. So our vertex is going to be negative 3, negative 2. Okay? So since we know the vertex, now we can think of this as shifts. So really this thing is going to the left 3 and down 2, right? Because that's our vertex at negative 3, negative 2, right? So this means left 2, down 2, left 3, sorry. And this is our shift, right? Because this is the describe the transformations from the parent function. It shifts left 3 and down 2. I'm actually now realizing that we did do over here on A, we knew that it shifts right 2, up 2, and then since it's negative, it also reflects over the x-axis. So whenever it's pointing down instead of pointing up, that means it reflects over the x-axis. I forgot to include that part on number 1. Okay, so on this one here, it shifts to the left 3, it shifts down 2, and then also, since there's a 2 out front, that means it stretches vertically by a factor of 2. So that also is included in our describe the transformation. Okay? And then, let's see, so we've got our vertex, and now our last part is just to sketch the graph. So we have our vertex, so we are, let's do this. We want to, I forgot about A again. I'm struggling a little bit here, sorry. Write each function in vertex form. So since we know it shifts to the left 3 and down 2, we can do this here, x squared. So since it goes to the left 3, that means this is negative 3. Negative 3 plus 3 gives us 0, and it shifts down 2, so that's going to be negative 2. And then this 2 right here, whatever's in the front out there, is going to just go right in here. Okay? Okay, so there's our vertex form. So that's for part A. And now that we have this, we can use this information here to finish off our graph. So from here, we're going to go up 2 over 1 and up 2 over 1 the other way. We can draw our little axis of symmetry right here, which we already found earlier. So now we need to find the last 2 points. So we want to find either negative 5, plug in negative 5 or negative 1 into our new form or the old. Either one will work just fine. So I'm just going to plug it into the new one that we have here, the vertex form, since it's right here. And I'm going to plug in negative 1. Negative 1 plus 3 squared minus 2. So negative 1 plus 3 is 2 squared minus 2. Got to square first before we multiply by 2. So this is going to be 2 times 2 squared is 4 minus 2. So that's going to be, y equals 8 minus 2, which gives us y equals 6. Okay, so at -1 and -1 for the x, we're going to get 6 for the y. Okay, and then that's a distance of 2 to the axis of symmetry, so we go over 2 more, and there's our 5th point, and then we sketch our graph. Okay. Okay. All right, that's all we have for the 11.3 vertex form worksheet for the odds. If you have any further questions, please feel free to ask. Thanks.